What? Meow. Why are you sitting on my phone? Alright, whatever. So, you're probably wondering what's happening. I came across this article where researchers developed a method to make heart valves in just under 10 minutes. And I think what's so cool about this whole process is that they use a technique that I haven't heard of before called focused rotary jet spinning. And after looking at it, I think I can do it and I really want to try doing it. So I'm going to do it anyways. I'm going to put together a plan, show you guys what I plan to do, how I plan to do it, and see if it works. Whoop, 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 Winnie! Wait, before I talk about making a plan, why on earth am I making a heart valve? Well, the researchers did it, and I think it's sick. I really want to try doing it, and I studied tissue engineering during school, so it's something I absolutely love doing. In reality, there are millions of people around the world with bad heart valves, and those heart valves will need to be replaced. But current replacements aren't too great. They tend to clot over time and wear out, ultimately resulting in another replacement 10 or so years later. So these researchers and many other researchers around the world are trying to make engineered materials that behave as cellular scaffolding. And what I mean by that is, at the cellular level, these engineered materials that make up the heart valves behave as guides and structures for the cells to adhere to. That means that when you implant one of these tissue engineered heart valves into patients, the patient's cells will integrate themselves and grow into this tissue scaffolding. Okay, but still, why on earth am I making a heart valve? Well, most heart valves are made of 3 flaps, where each flap is made of cells and a fibrous protein called collagen. Now, focused rotary jet spinning can produce fibers that both mimic the mechanical properties and the geometric properties of the collagen fibers found in these flaps, making it a good process to make these tissue engineered heart valves. And with that, let's get back to the plan. Alright, so here's the plan. Step 1 is to figure out how focused rotary jet spinning actually works. I have a few ideas, but I'm going to really have to dive into the research on it and figure out how they do it and try to reverse engineer it. That way for step 2, I can design my own and test out some ideas and then start designing the actual collector itself, which will collect all the fibers from the spinning process. Then I can finally start working on a heart valve. It's probably not going to go how the plan works, but that's how things work. That's how research is, and we're gonna have fun doing it, so can't complain. Focused rotary jet spinning. What is it, how does it work, and how can we use it to make a heart valve? So, focused rotary jet spinning is just a modified version of something called rotary jet spinning, and rotary jet spinning itself is really just a fancy cotton candy machine. And I'm going to explain how a cotton candy machine itself works before I start explaining how rotary jet spinning and focused jet spinning works. A cotton candy machine basically boils down to a few things. You start out with a small drum that has a few hundred little holes around the outside. And as you pour granulated sugar into the center of this drum, all the sugar gets pushed all the way to the outside. But since the granulated sugar is so big compared to the holes, the sugar doesn't fly out immediately. Instead, a heating element in the drum heats up the sugar until it turns into a liquid. And then that liquid can then pass through all the little holes on the drum. But the drum is spinning so fast that as the liquid oozes through the holes, it gets flung out to the side, leaving behind a trail of sugar fiber. And that sugar fiber can then be collected onto a stick and then eaten as cotton candy. And that's basically how a cotton candy machine works. Now, a rotary jet spinner works a very similar way. Instead of using granulated sugar, we use a polymer solution that's already in liquid form. That way, when you add the liquid solution to the spinning drum with all the holes on it, it instantly flies out the side, leaving behind fiber trails. Then you can collect those fibers and use them for any sort of application in biomedical engineering or tissue engineering or even chemical engineering. And that's how we get back to focused rotary jet spinning. Now, the main difference between the two methods is how you collect the fibers. With rotary jet spinning, you have these fibers flung out radially from the drum, so you have to collect them with a bigger drum on the outside. But with focused rotary jet spinning, you use compressed air to push the fibers in the direction that you want them to go. So we can push the fibers out from the page and point them towards the collection device that we want to make out of fibers. This way you can control how the fibers are deposited, giving different strengths and different morphologies that you're looking for. Hopefully that made sense. It probably didn't, but I think by the end of this video, you might get a good idea of what I'm talking about. I'm gonna start off with rotary jet spinning. That way I can get a device working that I can then use to turn on its side and use focused rotary jet spinning. We'll see how it goes, but I'm gonna start with this thing. Alright, it's been a few days, and this is the design for the rotary jet spinner that I came up with. All it is a small dish on top of a motor. That way, while the motor is spinning, the dish itself spins too, and on the dish itself, it has a cutout such that when I pour a polymer solution on the center, it gets funneled to the outsides while the motor is spinning and pushed through these two little holes on the outside. Once it gets pushed through the holes, it will get flung out to the outside, then leaving behind a polymer trail, which then cools into polymer fibers, and then those fibers can then be collected. So hopefully this thing works. It's my first design, so it probably won't work, but let's give it a shot. It kind of worked. Not really working. Just made a mess. Alright, so the current design isn't really working how I thought it would. When I add the polymer solution into the dish, it flies right back out the top instead of out the sides. So I'm going to redesign this, add a top to it so that liquid can't come back out the tops, and then hopefully retry. I don't know how it's gonna go, but you guys will see. Fibers! 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 Oh! Oh, yeah! Oh! Yes! Yes! Faster! Faster! Let's do 12 volts. Fibers. Oh, it's too fast. Hang on. No? Okay, that's too slow. Fibers! Fibers! Let's go! Let's go! Let's go! Oh my goodness. The lens! No! It's okay, as long as I have goggles on, it's fine, right? Let's go! Oh, it feels so good to have this done. It finally works and it's producing fibers. It made an absolute mess. I'm covered in fibers. So is my room and my desk, but it works, which means now I can move on to focused rotary jet spinning. How that's gonna work, I don't know. It's not a small feat, but let's figure it out. Actually, this made an absolute mess, so I'm gonna make a container to keep everything enclosed. That way it doesn't make a mess again, and I can keep testing. Alright, so it's been a while. It's been several weeks actually, so let me give you an update on what I've been up to. Over the last several weeks, I've been testing out different polymers to figure out A, what is the best polymer to use, B, what's the best polymer concentration, and C, what's the best rotary drum design to achieve the best fibers. Now, it's a pretty complex process and it's a reason why it's taken so long. So let me show you what I've been up to, what I've been doing, and more importantly, what I'm actually looking for in these fibers that makes them so special. Right, so here's the setup for the rotary jet spinner. Basically, it's just the box that contains all the fibers, that way they don't fly everywhere. And in the center of the box, we have this motor that's hooked up to this DC power supply. That way I can control the speed of the rotary jet spinner. And here's the drum itself. All it does is pop on the top like this, and I can hit start, and it starts to spin. Like, really, really, really fast. Like, so fast that I put on this thing. Okay, every polymer solution starts out in this stage. Here I have some stock PVA or polyvinyl alcohol, and I have a solvent, which is water, a beaker, and a balance. Here I'm weighing out some PVA, that way I can back calculate how much water I need to add to achieve a concentration of 12%. Now PVA takes a while to dissolve, so I'm gonna let this run overnight and then pour it into syringes in the morning. Now, the next step in the process is to make the actual rotary jet spinning drum. The way I do this is just resin-based printing on the Elegoo Mars 3. Then once it's done tomorrow, I can drill out some holes around the drum to allow the polymer to escape while the drum is spinning. Yes! Whoa! There it goes. Alright, so let me tell you what I'm looking for here. I'm looking for continuous web-like fibers that kind of look like cobwebs, so to say. And here I'm getting some, which is exactly what I'm looking for. Come on. Oh, you're so heavy. No, don't fall. Oops. What are you going? Right. Oh, why is this such a struggle? Okay. Phew. Whenever I look at the fibers underneath the microscope, I try to give myself a sense of scale or a sense of reference. In this case, I'm using a dime, and here's the dime underneath the microscope, and here are the fibers. So, as you can tell, these fibers are impossibly small. So small that I truly have no idea how thin they are. So, I think the next step is to move on to focused rotary jet spinning. And I promise I will do it this time. The fibers are nowhere near perfect, but I think they're good enough to get what I'm looking for in a heart valve. Alright, obviously I haven't made the focused rotary jet spinner yet, but I'm going to do that now. I'm going to design it up in Onshape this time. It's a new software for me, so bear with me while I get used to it. And then we can build the enclosure and start testing out focused rotary jet spinning. So, I don't know how it's going to go. It might go really bad, but fingers crossed. That is scary. Alright, let's try. Alright, it's making fibers. Oh! Holy sh**. Okay, it's kind of working, it's kind of working, it's kind of working. It's not working. I don't know what to do. Okay, you can't see me, but I think I got it. I think I got it. Let me show you. Let me show you. Let me show you. working. It's working! Oh my god, this is sick! Yes! Oh my god, yes! 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 Okay, so the difference between the two tests was that in the first test, I loaded the PVA solution directly into the disc before it started to spin, and in the second test, I hooked up the tubing that directly feeds polymer solution into the disc while it's being spinning, and it turns out that was all I needed. So I think the next step is to start coating stuff with PVA fibers. I'm like over the moon because this is the hardest project that I've worked on, and it's finally working. I am so excited. So let's do this. Okay, so I've been using an Apple to test it out, and it's working pretty well so far. There's a few minor issues, and I'll talk about that in a sec, but if you take a look at the fibers underneath the scope, you can see just how small they are, but there's one small issue, and that's all of these beads. So all these beads, though they might look pretty, pose a big issue as they can negatively impact the mechanical properties and the functional properties of these fibers. Now, the whole point of focused rotary jet spinning is to make nanofibers, or microscale fibers, which I'm probably doing, but regardless, these droplets pose a big issue. So to get rid of them, I'm going to increase the concentration of the polymer solution that I'm making and change the PVA's molecular weight. Now, the higher the molecular weight, the better a polymer is at forming fibers, to put it lightly. Don't quote me on that, there's a lot more to it, whoops, but that's the gist of it. So I'm going to make that solution right now and then get back to testing. So you guys will see what happens next. Alright, I know for an absolute fact that if I work on this, I can get this to work. But I'm kind of at a crossroads because right now I'm in iteration hell. I have tried various concentrations of PVA in water, various concentrations of PCl in acetone, and PCl in glacial acetic acid, and all of those aren't working. Now, the biggest problem is that I do all of this work in my bedroom. So the polymers that I'm using and the solvents have to be safe. So they have to be able for me to breathe and be fine. So I'm kind of limited in what materials I can test with. And I think in the future, when I have a much better lab space, that I will be able to do that. So I want to put this project on the back burner, come back to it in the future with more time, money, and more knowledge, and get a nice working heart valve rather than trudging through it right now and trying to get it to work in a mediocre way. So I still need to think about what my plan is, but I'm not sure if continuing this is worth the time and effort it is right now, if that makes sense. And that's me speaking candidly. So yeah, I'll get back to you.
So, is the video over? Yeah, kind of. Even though this project didn't really turn out how I wanted it, I'm still grateful for the amount that I learned. I learned an unbelievable amount about rotary jet spinning, focused rotary jet spinning, a lot more about polymers, quite the headache, but it was fun along the way. And when I make these videos, I film a little bit, and then I edit, and then film and edit. So I truly have no idea how a project's gonna go, how I get there, and how it's gonna end. So it was bound to happen that one of these projects would end up just not working, and I spent a few months making this video just for it not to work. So it's a tough pill to swallow, but I think in the future I'm gonna come back to this, I'm going to make it work, and I'm going to seed it with cells. That's the plan for the future. Hopefully you guys enjoyed. Please feel free to leave some comments in the... Please feel free to leave some feedback in the comments, both good and bad. How did you like the music? How did you like the pacing, the content, anything and everything? It helps a lot. I don't get offended. So please leave a comment. But with that, I think the video's over. So yeah, we'll get back to it with a new video. So let me know what you guys think I should do next time. But see ya!